All right, let's reflect for a moment on what exactly the markings we make on our Venn diagrams are signifying, what they mean. And this would be a really good opportunity to take some notes that'll prove helpful to you later on. When we shade out an area of a Venn diagram to reflect an A statement or an E statement, what we're saying with the shading is this area of the Venn diagram is empty. There's nothing here. We're shading it out to show that there's no members of this category that exist in this area of the Venn diagram. So when we shade out area 1, we push all of those S into area 2 right here. And we're saying all the S's that exist, they're all in area 2. And conversely, to show no S or P, we shade out area 2. We say there's nobody in area 2. We can turn out the lights because this area where the two circles overlap is empty. There are no S that are also P. Now, on the other hand, when we want to show a particular statement, like an I statement or an O statement, we mark a single X in the appropriate area. So we mark an X here in area 2 to show that there are some S that are also P. And we mark a single X here in area 1 when we want to show that there are some S that are not P. Okay? Now, it's important to reflect on what exactly that X means. The X means this. There is at least one member of this category right here where the X is. I don't know if there's more than one. I just know that there is at least one because the word some means at least one, maybe more, but at least one. Now, I want you to reflect back on that argument that we examined in the last lecture, the argument that had the universal premise, all students watching this lecture are people with interesting life stories, and it had a particular conclusion. Some students watching this lecture are people with interesting life stories. And we saw when we created a Venn diagram that looked like this, we saw that the premise statement did not necessarily imply the conclusion statement. We didn't see an X anywhere in that Venn diagram. And that confirmed for us that, yeah, this argument would be invalid from a Boolean standpoint. But the problem is that we also didn't see an X from the Aristotelian standpoint. And yet we know that argument is a valid argument from the Aristotelian standpoint by subalternation. So what do we need to do to our Venn diagram approach to be able to use Venn diagrams to confirm that that argument is valid from the Aristotelian standpoint? And the answer to that question is your new best friend, the circled X. Okay? Whereas X asserts that a plain X asserts that there's something there, a circled X says there is something here provided this thing actually exists. Okay? So a circled X is made of two components. It has an X that's performing a similar function to the plain X. It's saying there's at least one thing in this area of the Venn diagram. But that circle around the X is sort of like a caution or a caveat. It's a hedging of the bet. It's saying, yes, there is something here, provided there's anything here, okay? So when you look back at area 2 of our A statement, that's the only place where any S's can be, because all the S's are P. So from the Aristotelian standpoint, if we only argue about things, or we only make claims about things that exist in reality, and all S or P is our claim, then doesn't that mean that all the S that exist have to be right here in area 2? And if they're all in area 2 and they actually exist, then wouldn't there have to be at least one there? And that's what that circled X is saying. It's saying, okay, I've marked my S circle in such a manner as to create only one area where all of the S can be. They're all in area 2. And if they're all in area 2, there's got to be at least one there. And then the circle around the X is saying, provided S is referring something that actually exists and not something like unicorns or leprechauns. Similarly, when we mark no S or P, we create only one area where any S can be. All of the S that exist have to be in area 1. So if they're all there and they actually exist, wouldn't there have to be at least one there? So again, from the Aristotelian standpoint, if we mark our Venn diagram in such a manner as to create only one possible area where any members of the subject category can be, we can put that circled X there. And that circled X is saying, okay, because they're all here, there's at least one here, provided there's any of them that exist in reality at all. And so from the Aristotelian standpoint, we're going to be able to use circled x's, not from the Boolean standpoint. So now go back to our argument about students. And we can see here from the Boolean standpoint, we create a Venn diagram that looks like this. We never mark the conclusion, only the premise. And we can see that this argument, or this Venn diagram, reflects the premise, but not the conclusion. We don't see some S or P here. And that tells us that from the Boolean standpoint, this argument is invalid. But I can keep thinking about this argument from the Aristotelian standpoint. And I can ask myself, is there any area of the S circle that's the only area where any S's can be? And the answer is yeah, that's area 2. So I'm going to put a circled X in area 2 because according to this argument, all S are P. And if all the S that exist are right here in area 2, there's got to be at least one there, provided that they exist. And now I see my conclusion statement, and that tells me this argument is conditionally valid. That means it's valid from the Aristotelian standpoint only, and it's valid on the condition that the thing that is referred to by the subject term actually exists in reality. And in this case, students watching this lecture, you're one of them. So this argument meets the criteria or the condition for validity from the Aristotelian standpoint. Now look at how this argument works. This argument has an E statement for a premise and an O statement for a conclusion. No seahorses are peacocks, therefore some seahorses are not peacocks. Okay, so we'll symbolize out our argument to make it easy to work with. No S or P, some S are not P, and we create our Venn diagram, and sure shooting, when we do so, we do not see the conclusion reflected here. That tells us that this argument is invalid from the Boolean standpoint, right? And it has that form, again, it has that universal premise and that particular conclusion, always invalid from the Boolean standpoint, the existential fallacy. But when we look at this diagram here, we see that after we've shaded in to indicate the premise, there's only one area where all the S's are, area 1. All the S's that exist in area 1, all the S's that exist in area 1. So if they're all there, there's got to be at least one there, provided they exist. And that's what that circle around the X says. It's provided they exist. I'm sort of giving you a caution here. Now I see my conclusion statement. Some seahorses are not peacocks. And that tells me this argument is conditionally valid from the Aristotelian standpoint only. And the condition that has to be met for this argument to be valid from the Aristotelian standpoint is that seahorses have to actually exist. And thank goodness they do. So this argument meets the condition for validity from the Aristotelian standpoint. Now, when you're operating from the Boolean standpoint and you create an A claim, you're going to have a Venn diagram that looks like this always. You're never going to have a Venn diagram that looks like that. That works from the Aristotelian only because the Aristotelian is looking at this area 2 of the A statement and saying, well, gee whiz, if we only talk about things that exist and you're telling me that all of the S exist here in area 2, then there's got to be at least one there, provided there's any of them there, okay? So your A statements and your E statements are going to look different in a Venn diagram depending on whether you're operating from the Boolean or the Aristotelian standpoint, okay? You're never going to put a circled X when there is more than one area of a circle where anything could be, okay? So you look here, area 2 is the only area where any S's can be. So we can mark a circled X there, okay? But we don't know if there's anything in area 3 or not. There might be, but maybe all the P's are here in area 2, and maybe area 3 is empty. We just don't have enough information. So we can't mark a circled X in any area of a Venn diagram when there's more than one area that's been left unshaded for that particular circle, okay? Similarly, when we mark some S or P from a Boolean or an Aristotelian standpoint, we're going to use a plain X in the appropriate area. We're never going to mark a circled X to show some S or P, ever, 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 because when we mark some S or P, we've got areas that are still left unshaded here. Maybe there's S over here. We don't know. Maybe there's S's here in area 2. Maybe there's some in area 1 as well. We just don't know. Similarly, when we mark some S or not P, we're going to mark a plain X. That's asserting there is something here. Some S are not P. We're never going to use a circled X to show some S or not P. We're never going to use a circled X when we're operating from the Boolean standpoint, only the Aristotelian standpoint. And heavens forbid you ever do something like this, where you mark a bunch of circled X's in areas of circles where there's more than one area that's been left unshaded, okay? So if there's more than one area left unshaded, you do not get to mark a circled X. But if there's only one area that's been left unshaded, that's an area that can get a circled X.